This mini lecture is on triangulation. This is chapter 5.8 in your textbook. We use an instrument called a seismograph to record earthquakes. Seis is again a root word meaning shake or quake. Graph is a root word meaning write or instrument. So this is an instrument that writes or records shaking or quaking. So take a look at the picture and tell me what is actually moving during an earthquake. So here we have a very heavy ball hanging from a string. So gravity is always going to pull this heavy ball to the center of the earth. During an earthquake, the ground will move back and forth, and thus the paper will move back and forth. So the ball stays still and the paper moves. So if ever you see in a movie a seismograph in which the pen is shaking back and forth, really it's the earth shaking back and forth and the pen is staying still. The next topic I'll talk about is triangulation, which is how we find the center of an earthquake. So first I need to talk about seismograms. Seis, again, is a root word meaning shake or quake. Gram is a root word meaning something written down or recorded. So a seismogram is what the seismograph records, is the paper coming out of a seismograph. So when looking at seismograms, we need to determine the time that the P wave arrives and the time that the S wave arrives. The primary wave is the first wave to reach a seismograph because it's the fastest. Secondary waves are the second fastest, so they're the second one to arrive, and surface waves are the slowest, so they're the last to arrive. The farther apart the waves are, the farther the location is from the epicenter. Imagine you and your friend are at the starting line of a race. You are going to walk and your friend's going to run. At the very beginning, pretend that starting line is your epicenter. You guys are right next to each other. Therefore, you're really close to the epicenter. You're on the epicenter. Imagine 5 seconds into the race. You are walking and your friend is running, so your friend is going to be farther ahead from you. But they're not going to be that far ahead of you. Now imagine a minute into the race. Your friend is still running and you're still walking. You may not even be able to see your friend at that point. Therefore, the time between the S wave and the P wave is really large. Therefore, you're really far away from the epicenter or the starting line. We know the speeds of waves, so all we have to do is record the time between the arrival of the P wave and S wave, and we can calculate the distance to the epicenter. Here's an example of a seismogram. You may see little squigglies here, but that's normal. When the lines start jumping up and down, that's the arrival of the P wave. Then you may see it calm down a little bit, and it jumps back up and down again. That's the S wave. And sometimes you'll see it calm down and jump up a third time. That's the surface wave. You don't always see the surface waves, however. We're mainly concerned about the P waves and the S waves. An SP lag time is something we need to calculate in order to find the distance to the epicenter. SP lag time means the arrival of the S wave minus the arrival of the P wave. So first we have to figure out when the P wave arrives. So when the lines first start jumping, you read the time that the P wave arrives. And the S waves, you read the time that the S waves arrive. Then all you have to do is take the big number minus the small number, S wave minus P wave, and you get the SP lag time. Okay, take a look at these two seismograms and determine which location is closer to the epicenter. Is it Montreal or New York? To determine which one's closer, we have to look at the SP lag time. So first, let's look at the P wave. The P wave arrives at about 15 minutes. The S wave arrives at about 140 minutes. So if you subtract those two, you'll get 125 minutes. Now let's look at New York. P wave is about 45 minutes. The S wave is about 245 minutes. Subtract those two, you get 200 minutes. So the correct answer is Montreal because it has a lower SP lag time. Now to continue on with our triangulation, we have to use our SP lag time to determine the distance from the epicenter. You need 3 seismograph stations to do this. This is why it's called triangulate, because tri means 3. Okay, so to triangulate, first you would need to find your SP lag times using the seismograms, like we just did. Once you get your SP lag times, then you have to read your graph. For example, let's say for our first location, our SP lag time was 40 seconds. On your graph, you go up to 40 seconds, follow it over till you hit that dotted dashed line, and follow it down. So our distance was about 390 kilometers. So at your first location, you would measure out 390 kilometers. Then you would draw a circle with a radius of 390 kilometers. Then you would go on to station 2. Let's say station 2 had an SP lag time of 50 kilometers. You go up to 50, over to your diagonal line, and down. So about 480 kilometers. So at your second station, you would find the radius of 480 kilometers and draw your circle. At this point, you narrowed down the location of the epicenter to 2 locations, right here and right here. You don't know which spot it is, so you have to have a third station to narrow it down. So let's say your third station has an SP lag time of 55 seconds. Go up to 55 seconds, over till it hits your diagonal line, and down. So we get about 540 kilometers. So again, using your scale on your map, you draw a radius of 540 kilometers, and draw your circle. Now where all 3 circles intersect, that will be the location of your epicenter.